Here's problem 3615. Bottles of perfume sometimes have thick glass, n equal to 1.5 index of refraction, walls which give the impression that the volume is larger than it actually is. Assume a cylindrical bottle has an inner radius of 1 centimeter and an outer radius of 2 centimeters. How thick in centimeters would the wall appear if you could see a mark on the inside surface? Alright, so let's take a look at this cross-section of this bottle. We have an inner radius of 1 centimeter and an outer radius of 2 centimeters. If I were to look at a wall of this bottle, it might look something like this, where it's actually thinner on the inside than it is on the outside. Hence, that would be the signature of a diverging lens. And in fact, if we were to look at a spot on the inner surface, imagining that we're going to view this light after it's passed through this glass, our light is actually going from left to right through this diverging lens. Hence, from that light direction, we can imagine that the first radius will have a center of curvature that's located on the left-hand side, not on the side of the outgoing rays. So our radius 1 is going to equal a negative 1 centimeter. Our second radius of curvature is going to have a center of curvature located on the left-hand side, not on the side of the outgoing rays. So that radius will also be negative. That will be a negative 2 centimeters. So as we look at this, we have our lens maker equation. 1 over the focal length is equal to n minus 1, 1 over R1 minus 1 over R2. Calculating this, we have 1 over the focal length is equal to 1.5 minus 1, 1 over a negative 1 minus 1 over a negative 2. So this will be equal to 0.5 times a negative 1 plus 1/2, negative negative. So this will be 0.5 times a negative 0.5, or a negative 0.25. So our focal length will be 1 over this, 1 over a negative 0.25, which would be 1 over a negative 1/4, which will give us a negative 4. So the focal length of this lens is a negative 4. Since the focal length is less than 0, that is indeed a diverging lens. Nice to know. So we have ourselves a diverging lens. If we apply the thin lens formula to this, 1 over P plus 1 over Q is equal to 1 over F. Let's solve this for the image distance. So 1 over Q is going to equal 1 over a negative 4 minus 1 over P, which is 1 over, and then we're going to assume that we are 1 centimeter for our object distance. So that's 1 over 1. So that's going to be a negative 1/4 minus 4/4, which would be a negative 5/4 for 1 over Q. So Q is going to equal a negative 4/5, or a negative 0.8 centimeters. Negative means it's not on the side of the outgoing light, so it's actually on the inner surface. And in fact, or inside the lens. In fact, the location would be right about where this dot is right here, and hence it would actually make it appear like the inner volume of this perfume bottle was bigger than it actually was. It would make it, instead of 1 centimeter radius on the inner volume, it would make it look like it was 1.2 centimeter radius on the inner volume. So how thick in centimeters would the wall appear if you could see a mark on the inside surface? The wall would appear like it was only 0.8 centimeters thick rather than 1 centimeter thick. So that's our answer, 0.8 centimeters.